Hello, my name is Nicholas. This is my partner,
Hi, I'm Akshay.
and today we are presenting our EC 176 final project, Programming and AI to Play the Game of Othello. What is Othello? Well, this game is played on an 8x8 checkerboard with black and white discs. Players surround the other discs with their own to flip them to their color. The game is complete when the board is completely filled or there are no more valid moves, and the player with the most discs of their color wins. What we're hoping to achieve here is three-step. Firstly, to represent this 8x8 board state as a pseudo image input. These board states will be our data, and then train a CNN network with existing expert game moves to play, essentially our labels. We will be measuring the performance quantitatively, of course, but also qualitatively with a movie later on. Our ultimate goal is to achieve AI performance equal to or greater than expert level gameplay.
So now I'm going to be talking about how we designed the CNN and how we constructed a data set. So we first used a Kaggle data set that contained expert games from an online Othello website, and it's formatted as a CSV with a list of game moves using chess notation. So we took all of these game moves, and for each move, we made a board state and converted this into a 3x8x8 matrix the CNN model can learn from. The first channel is a binary matrix for the player positions, which are ones for where all the player tiles are and zero for everything else. And then second channel is similar, except it's a binary matrix for the opponent positions. And then the third channel is just a regularization channel of ones. And then we also converted every corresponding game move for this current bird state to a 0 to 59 label, as you can see in this image shown there. We also performed data augmentation to increase the size of our data set. So we did an eightfold increase of training data by adding three rotations of 90 degrees, 180 degrees, and 270 degrees, and also added horizontal, vertical, and diagonal reflections. And then all the stuff I talked about is ideas borrowed from a research paper that we cite in our paper. And this literature suggests that CNNs are suitable to learn to play Othello because by building these 3x8x8 matrices, the CNN is able to learn the board state, and it's similar to an RGB photo.
Also inspired by the literature was our CNN structure. As you can see in the table, there are 8 convolutional layers followed by 2 fully connected layers. For all the layers except the last one, we use a stride of 1. That last one uses a stride of 2 because we found that this increased performance. And similarly, all the layers except the first one use a kernel size of 3 by 3. We found that the stride of 2 decreased the feature map size to a 4 by 4, and this really helped the network to understand the most important parts of the Othello board and filter out any unnecessary information. We performed convolution, batch normalization, and ReLU for every convolutional layer, and then of course used vanilla batch normalization for the FCNs. We implemented stochastic weighted averaging on our model, which, as actually will show in the next slide, also increased performance.
So now we'll go into the performance of our Othello network. So we defined three metrics to evaluate our model. The first is classification accuracy, which is just how many correct predictions do we make. And then the top three accuracy takes the top three confident predictions and checks if the label is within those top three confidence predictions. And then the top five accuracy is similar, except we take the top five most confident predictions. And then model one is just the baseline model from the research paper. Model two adds stochastic weighted averaging to this model. And then model three is just the same as model two, but adds the change of strides and kernel size, as Nick said before. And then model four is trained with data augmentation. We found that data augmentation increased the performance of our model the most. And this is just because we increased the data set size from 1 million to 8 million. So this really helped the network learn more examples. And now we'll show a video of us playing against the Othello network. So the AI is the white player, and then we're the black player.
As you can see, the AI responds really quickly. We measured an average inference time on the order of 10 milliseconds. And this Othello checkerboard is something we built, so you can play against our AI as well. All the code is on GitHub.
And then we also have other examples of our AI playing against us, but this is just one game. And as you can see, the AI beat us pretty easily. So yeah, that about sums it up. Thank you for watching.
Thank you so much. Have a nice one.